On n'avait pas alors. Pourquoi t'as mis une casquette?
Pourquoi tu rigoles?
Mais je rigole pas, je me.
T'es tous en rigolant.
Je peux finir les 9 minutes ou je dois aller de l'autre côté? Qu'est-ce que tu préfères?
Ben,
Tu préfères que je finisse de l'autre côté?
si ça t'embête pas, mon chéri d'amour que j'aime tant. Je te mets pas dehors, hein.
Non, mais c'est pas grave. Je m'en vais. Coming back soon, ok, mais moi aussi je vais revenir coming back soon. Non, mais je m'en vais. Vous restez avec votre père. Comme je suis expédié de l'autre côté.
T'es pas expédié de l'autre côté, bébé. T'es pas expédié de l'autre côté.
Ils montent pas dans le canapé, hein.
Oui, oui, t'inquiète pas.
T'as prévu la pêche pour quand on voit des sextapes ou quoi?
Pour filmer le panneau.
Ah, je pensais que c'était pour les sextapes. Ça me plairait bien, ce qu'ils font.
Je veux bien que tu te connectes sur YouTube, s'il te plaît, sur ton téléphone, et que...
Je crois pas, j'ai pas le temps, je vais aller voir. J'ai plus le téléphone, mais tu sais.
N'importe quoi.
Et qu'est-ce qu'il veut que je fasse sur YouTube?
Que tu vois si... quand je vais parler, si tu m'entends bien, mais il faut pas que tu te mettes autre part. Bah tu vas sur YouTube. T'es pas abonné à ma chaîne sur YouTube?
Je suis pas un geek comme toi.
Non, c'est bon, ça fonctionne. C'est bon.
Ça marche.
International.
De la Kim Kardashian internationale. J'éteins la télé et tout, du coup, il faut qu'il y ait le moins de.
S'il te plaît.
Donc, je m'en vais, quoi.
Tu sais que là, on entend tout le monde. Tu peux mettre une chaise et me regarder. Like this. No, like this. No, it's better like this. Okay. Good evening, everybody. Tonight I would like to talk more about the scripting of LEDs, meaning like we know how to program LED quite easily, simply using the Arduino IDE or Platformio or whatever you use, or ESP IDF, for instance, if you're using an ESP32 or an ESP8266. But there is no official way of doing scripting, live scripting, meaning like you could store the your animation program and execute it live, and you can have several of them and execute them without having to reload everything within having to recompile and reload everything within the MCU. I know that there have been on, especially on Reddit, some try using what's the name of that already? Just a minute. Okay, I have an issue with my light. Some try using Lua and other. So I've tried them. We're going to look at them. We're going to see the issue with them. And then we're going to try to see if we've got a better way of achieving the scripting language to do live animation. Okay, let's try to do that. Okay, let's unplug first that. I'm just going to set up my camera for my panel. Yes. Good. Okay, sorry, it's better like this. So first things first, what we're gonna do the symbol rainbow animation using the Arduino IDE and an ESP32. For information, here I'm running 12,000 LEDs, more or less. So let's start with the easy part of it. So I'm gonna add Arduino Gravity. Let me find the basic console. That's not what I want. I want the original sketch. So window. Okay. Let's add this. Okay. So here we see a usual, I would say, a very simple rainbow animation that goes through the different LEDs. It's nothing really special, but there is nothing really special about it. Let's launch it and see what happens. Let's put that below here. Below serial first. Okay, I'm gonna shut down the serial for now. Okay, okay. Let's launch the implementation. I'm going to move the camera a little bit. So it's uploading. And here is, oh, no, I didn't put the rainbow animation totally. So let's rapidly change the code to put the rainbow animation that I would like to have. So here, it's HSV plus off 255, 255. It's gonna be a bit more colorful. So here I'm running the full upload on the ESP32. Yeah, here it is. Okay. I'm going to bring back. I'm going to bring back the serial, remove that. Yes, and here I'm connected to the ESP32 in serial. So you see that we take 12 milliseconds to execute the calculation of the 12,000 LEDs. And why don't I see the camera anymore? Because it's serial. iPhone, yes, better. Right. Oh, shoot, that should be here. Yes, sorry. So that's the speed. So it's more or less 85 FPS to do the calculation, which is not too bad. Let's try another way of doing it. Actually, I'm going to use here Mercury. No, Gravity. I always say Mercury. Gravity. With a scripting language that is more or less here. There's Gravity. But it's actually pre-compiled. So you go from the code to a pseudocode, and the pseudocode is interpreted within the MCU. So here is what's going to be executed. If I found the code, here is the code that's going to be executed. So more or less the same thing as before. So now I'm going to run that and see how long does it take to actually execute. Oh, I cannot upload because I'm plugged into, I need to shut down the connection to the serial connection to the ESP32 for it to work correctly. So I'm gonna relaunch that. I'm gonna move my windows around. It's gonna be easier for me. Okay, here it goes, it's uploading. And here it is. So I'm gonna get here. Oh, shoot. There it is. So here you see it's really slow. And if I reconnect the serial, you see it's taking 161 milliseconds per to do the full calculation of one frame. So it's really slow. I've done that also in Lua, and in Lua it's even worse. It's taking 400 milliseconds per run to do the same script. Okay, so that's not really what we would like to achieve. So what we would like to achieve, if we could do something like this, would be let's try to put what we would like to have in terms of capabilities for our engine. So I'm just going to put a new window here and a new file. How it's okay. Get files. And I'm just going to add the file, so we're going to see new capture. Okay. Pop. Okay. So what we would like to have as a scripting language. So it should be fast, easy to write down, portable, yeah, come back, easy to write, meaning in the framework of Arduino or Platformio, we're using C. So if we could have a language which is close to C, would be nice. Fast as almost as if I execute it directly, like it's compiled directly on the MCU. Portable, I would like to be able to export like easily, like in a script, to export the script or directly the program to another MCU. So let's start with that. So, and maybe for an environment on the MCU, with, I would say, OS-like capabilities. Okay, so that's what I would like to achieve if it's possible. So I'm glad to introduce what I'm calling the LED OS. So let's see what it is and let's see how we make it work. So I'm just going to get rid of that for the moment. And I'm going to add a new capture, which is okay. Arduino IDE, and I want this one. Okay, so I'm gonna upload that file. Test.sm parser. It's just gonna take a little while to upload, but it's gonna be fast afterwards. Oh, the port does not exist. Oh, what have I done? Yes, oh, I guess again, I am linked to, yes, it's plugged in here. So I'm gonna re-upload the sketch. Because if I remove, oh God, I'm not uploading the right sketch. Sorry, I'm uploading the wrong sketch. Okay, seems good. Let's get rid of this now. Okay, now I'm going to connect back to my ESP32. Nothing happens. Double click, you can see that I have a prompt, which I call LED OS. Yes, because it's a LED OS. What can I do? I can list what's inside the SPIF memory, but I could actually connect to the SD card. The console-like, I would say, functionalities are separate from the interpretation of the scripting that I've put into place, but I will see what we can do. So what I'm going to do first is I'm going to look at that file. That's way too complicated. So there is a mini editor, and I'm going to take the script that I was using in my original Arduino IDE sketch, which is this one. See, so here I can copy. So here is the script that I'm using in my original Arduino IDE. So here I'm on the ESP32. This mini editor is running directly in a terminal within the ESP32. So what I'm going to do, I'm going to say, okay, I'm going to, like in C, create a new function, void main. Okay, I've got my two loops. I'm going to have to do a change here, but I will come to that later. Void main, and now there is an offset that I need to. So the offset, which is here, for the moment, I'm going to do a loop over that offset. So I'm going to add a new layer for the offset of less than, let's say 1000 of plus, one more layer of 44. I would love, once this loop is done, I would like actually to show, so I'm going to say show. Okay, but what are lets and what are shows? So in my scripting language, like in for Lua or for Gravity, you can define external variables. So I'm going to say ext. I'm going to define the variable lets. But what is lets? Lets are the RGB. They are a pointer to CRGB. Okay. I'm not going to implement the show function, so I need to also get the show function, show, comma, up. Okay. And I'm going to add a couple of more functions for here, because the function HSV does not exist, because it's kind of complicated to translate from hue saturation to RGB. Okay. And I need to do also a little thing for the moment. That's RGB. Let's OP. Okay, I'm almost there. And now what I need to do is to call the SHV function. Okay, here I'm gonna add. Okay, here I'm gonna add that. Voilà. E plus G plus off. Oh, I see. Oh, I did a mistake. A plus G plus off plus G plus off, and I need to do this one. That's a trick that I need to do for the moment. In the next version of the run, I will not be able. I will not have to do that. So here it's off plus plus. What did I do? Okay. So now I can exit. If I come back, I see the script. I can exit by Control P. I'm gonna save, like I'm gonna say live example. Okay. If I do an ls now, I can see that here is my live example here. And now I'm totally on the ESP32 here, nothing done. And if I haven't done too many things, too many issues, too many problems, I would say, I should be able to do this. And you see it's running, and you see that it's taking 16 milliseconds to run. It's not exactly the same. I know why. I'm just gonna let that run by itself first. Control P. And I'm gonna change the value from 270 to 255 here. I exit, I compile, and here it is. It looks better than this. Okay, so what is happening actually right now is actually that the code is running kind of 10 times faster than Gravity, so it's more like 40 times faster than what we could do in Lua, and it's only a couple of milliseconds slower than the whatever than the real one. Okay, so if I go first to my no, I want full. Oh gosh, I'm losing it. Okay, here, fast. In the fast category, here, the first, so Lua was 400 milliseconds per frame, Mercury 160 milliseconds. I would say native 12 milliseconds, and new one 16, let's say 16 milliseconds. Okay, so the new scripting language is actually really fast. As you can see, it's really easy and close to C. If I come back to the language that you were using, go back to here. I go back to the editor of the terminal editor within the SP32, as I said. You know, it's more or less a copy paste of C language. Okay, I will come back later on what I've done already and not done yet, because not everything is finalized yet, but a bunch of them has done. Okay, so if I go back here, I say here we can say that's an okay. Portable, I still have to work on that, and an environment in the MCU using like OS capabilities. It's okay with a small okay, still working on it. Okay. So portable, that's something that I'm going to discuss later on, because that's the next version of the parser and the scripting language. Okay. So how come this is, I would say, so fast compared to what I've done before the other languages? It's really, I would say, kind of simple in a way. Normally, Lua works like this. It's actually each line is interpreted. Via C language. Okay. Mercury. First, they've got, I would say, precompile phase. That produces, I would say, pseudo code. And the pseudocode is interpreted. In the native one, it's full. It's C++ to matching language matching language. That's why it's so fast and it's optimized. Okay. In this new one, what do I do? It's it's C-like, let's say. It's not C++, it's C-like. To assembly language to machine language. So I've recreated, I would say, a full compiler, assembler to actually change this into machine language. Okay, I'm going to show you that this is true. So if I go back, I'm going to just going to change one parameter into the compiler. Show, here it is. You will see the true. I'm relaunching, I'm re-uploading the program so you can see the output of the compiling. That's why I say compile and not something else. I'm going to do also something. I'm going to remove the display of the time within the show. This way I do not pollute too much the user interface. It's coming, it's coming, it's coming. It's uploading within the server. Okay, done. Can go back in here. Body, ls. I'm gonna load again my live example. Still here, I'm on the ESP32, and that's running directly on the ESP32. I can edit it. That is the code I've wrote before. And if I do compile this time, here it is. You could see that it's running on the back, but here is the assembly code, which is actually generated. And you can see tokenization, parsing, for those who know compiler, compiling, do some cleaning. I create an executable, and that the executable is based on this machine language, on this assembler here, assembly language here. And then it's running the function, the specific address. So what I've managed to do is actually able to create a standalone assembly program to be able, this program can call external functions, because the show function is not internally, I've not rewritten the show functions, for instance, and I was able to call it from my assembly program and return also and continue my calculation. So here you can see, if I go back to the program, because I didn't save it with 255, okay. It's running. Now it's executing the code. Once the code has been actually compiled, is somewhere in memory. I'm waiting because I've got 1000 iteration. Here, I don't need to recompile the code if I want to re-execute it. I can just say run. And it will automatically launch again the same program, because internally the memory hasn't changed. So I just need to rerun it. So here you can see that you've got in term, if I go back to that, in terms of portability, I could actually store my C program within an SD card. And just load them and compile them automatically. That's what we can do. Okay. Now I need to show you. I need to explain to you what's behind a couple of the functions that I went quite fast through. Going back to my program, here you see a bunch of extern. How do I define that? So, of course, it's a question that I'm wondering in the architecture of the scripting. Will I be able to define the let buffer directly within the scripting, or do I have my let buffer, which is actually already defined within my main program? That's something that I need to discuss. As I said, HSV is not a function that I've rewritten within the compiler because it's kind of complicated and I don't want to do that. So, but what you can do easily, I'm just going to show you that. It's actually, I guess I've got it here. Here it is. Here you can see that with these commands, I'm adding the external functions of my I'm adding the external functions. So let is an external value. OP, I will come back later on that one. I could say the width also showing external value if you want to define it as a constant. Here is a show function. I've got display functions, start program functions that I'm needed to use for that. And if I go to the show functions here, if I look at the show function, here I'm using my driver, but here you can have fastlet show pixels or fastlet.show or whatever program you use actually to display your functions. Okay, so it's nothing really complicated to do so. So you can really, I've got also the clear functions that I wanted to simplify here instead of rewriting the loop to clear the let if I wanted to. So now, because I've defined it here, I can call it using within definition here. I can just say here ext void clear. Okay, I can also use functions that I can pass value in and out, like these ones, for instance. I'm able to get the value back from the functions that I'm calling. To also, I'm able to call an external function, but also I'm also able to call internal functions within the program. So let's go back here. I'm gonna clean. I'm gonna load S7, I think. Yes. Here, yeah, it looks like really a Unix editor. I've got my inspiration from that. Okay, so yeah, I'm calling the OP. I will display the display because if I want to display some information within within the console. So if I've got a small function that draws rectangles, okay, with taking a size and an offset for the color. Here is my main function with the same loop as before, more or less. And here I'm calling the fact to create a 60 rectangle with a variable size. Okay. And so now I can just, because I need to compile that program, this program does not exist yet. I need to compile. And here it is. So I'm drawing still with the background, I would say the rainbow background. I'm creating the new set of rectangles within. I have an issue with my lamps and control center. What's going on? That I can quit. Caster. I'm gonna write it like that. Otherwise, I'm not sure. Okay. Okay, it's better like this. So now okay, it's stopped and I can just rerun it. I'm here, can just run it again and it starts again. And it's quite fast also. It's taking like 60 milliseconds to do all of that. And I can also execute the program on the second core, but I will need to manage the killing of the program. I've got a couple of issues on that one when I want to restart the program. It's not really clean on the restart size. I need to see why, but I'm working on that. I still need to add some functions within the compiler to have a more full C programming language. Let me show you what I'm missing still. Here it is. What I need to do. Actually add a couple of functions. I'm missing if then else. I'm missing the while function that I want to add. I'm missing the fact that if I'm calling a function, an external function that returns an object instead of just a value, but an object like a CRGB, I need to go through an external variable, which is not what I'd love to do. For instance, in here, if you look at what I've done here, if I look at that, if you look at this function here, that and this here, when I do that, actually is calculating the result of the C U saturation value within the first, I would say, the first entry of this array. And I would love to be able to write. I would love to be able to write this instead. Let's lm equal hsv. Blah, 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 blah. I would love to be able to write that, but I'm not able yet because the external function returns, I would say, a structure and not a value. I need to work on that. I also need to add that's the first one. I need to add also the capabilities of having large initialization of array, meaning like let's say that CRGB, I would say palette equal CRGB geometry, stuff like this. I would love to be able to write that. For the moment, I can't. For the moment, what I need to do is actually to define the palette and then enter each time the value, like in this small program here. Type just like in here. Okay, if you see here, I needed to enter each value of the array to be able to go through them instead of actually simply being able to write it like a normal entry. Oh, I can get that, but this program doesn't load. There's two. But I guess it goes too fast. So if I am running that, this will go very fast. Compile that. Oh, shoot, what's going on? First issue. This two. What's going on? It's not perfect yet, so I've got a couple of issues with some part of the program. I will need to see why. But it was running before, so I don't know why. Interesting. Test. That's okay. K2, that seems correct. Display array. Why is it not working anymore? Because I managed to have it work. Color, clear, plus. There is something it doesn't like, but I don't see it right away. It's correct, main. Interesting. I don't know why you can't compile it. Something's wrong. Okay, I need to see why. That is strange. This is really strange. Let's 7. Compile. Okay, that's working. I don't know, like I need to check why as a test tool did not work, because it used to work before. Interesting. Okay, I need to see what's the issue on that one. I'm still, that's still the beta version of the program, so I don't know what the issue is for him. After the tokenization, so the parsing, he had an issue with the parsing. Node test 2. Display exists. Okay, let's do that sometimes. Int pos equal I plus K2 percentage 4 modulo 4. Okay, we will show that. What happened in that case is actually that I'm still working on it, because while writing a compiler on your laptop, I wrote it on my laptop, so hopefully that memory is really large, so you don't have any issue with recursivity. But that does not work correctly. Recursivity does not work correctly on the MCU, because it requires too much memory in the stack, and sometimes you've got a stack canary, no more memory within the stack. So I need to split, instead of putting the expression I plus K2 modulo 4 within the bracket, I need to put it outside of the bracket and then request it here. That's something also I'm working on to try to understand why it happens sometimes and not others, because I had to flatten totally the to remove all recursivity for creating the I would say the tree of parsing, which was quite a large work because I've based everything on that tree before, but I had to redo everything. But yes, but it's working, and as you can see, you've got 4 colors, even if the light is not the correct one, but we've got 4 colors here, which works fine. Okay, so sometime for the moment I need to adapt, so that's also something that I need to add into my list of things to add, meaning check recursivity to avoid canary stack. And also I would love to add all the, because on my driver you can switch the easily the LED buffer that you're using. You've got a couple of functionality like this, so I would like also to add also this functionality. That's not the most complicated one, but I need to also work on that. Yes, that's merely everything for the moment. So the writer is actually now on the SP32. We've got an editor, and the editor is totally separated from the parser. Yeah, you can really imagine that. You don't have to use the parser. You don't have to use the console and the editor to write that. You can write your code within in C, for instance, in your Visual Studio, and then store them in the SD card, and then put them in here. Yeah, one thing that I want to add also is actually that I want to be able to export the language machine directly. If you want to share your animation with someone else, but you don't want maybe to share the code, you will be able to share the language machine part as a binary, and we'll be able to execute it directly on his computer without having to do anything. But I need to work on the format of everything that I need to do, because on top of the, I would say, the code, I've added the way of creating a stack within the, I would say, not 32 byte line memory. So I need to work on that, and I would love to do like for the Pico 8, when you can actually store the program within a JPEG or something. I would love to be able to do the same thing for the animation, something more or less identical for the animation. Yes. What else I wanted to say here and here? So now, yeah, if you've got here the editor, we don't have to use it to do the compilation, because that's totally separated. Just that the console here, the LED OS, you can do more or less everything inside of it. I'm gonna continue to improve on that LED OS, meaning better editor, being able to have several scripts at the same time. Let me show you something first. So here are purely language machine here. And if you want, you can directly write assembly, and you can parse the assembly. So you can do parse ASM. I've got error code. Oh yes, because I've changed that. Parse ASM. That's an old stuff. Try line 6, line 10. That should be working. The word doesn't exist anymore. No, not executable already because it could not compile. Let me see what else do I have here, which is not load for. this should be something, and then I can do parse ASM. Yes, and I can run. Okay, but it's nothing really special, so it doesn't really, nothing really doesn't happen in that one. Okay. Oh, it's run. Oh, yes, because yes, I'm gonna, because I've defined that I'm executing always the main function each time. Here it is. Now it's running. Fine. Okay. So you can, if you want to write assembly language, you can directly write assembly language, which is not something that I, but I'm wondering why the first prog does not work correctly. What's his issue? So I was saying I'm going to improve again on the editor because I still have some issue with it. I would love to be able to have more than okay, so I'm going to do bytes 8. Because I don't understand why it wants. Maybe was something special within the parse ISM. Line 7, line 10. I don't know what's going on. Ah! No, it's not that. Okay. Right, so. Maybe 11. Let's 7 bytes. Okay, something is wrong, but I don't know what exactly. It's not bytes. Let me check something because I'm wondering. Oh, it's that's very ugly behind me. Gonna change the color of that. Load A7. Compile. Okay, better. Anyway, normally you can write, just that I guess I've got some I guess there are some tabulation within the stuff. That's why it doesn't understand. Load first. Maybe there are tabulations. Line 3, line 9. C'est line 3, line 9. I don't know what's going on in line 3. I know it is, but there is an issue because I don't think the okay, something is totally wrong here in here. It's not gonna work anyway, but I changed that so that it was a null assembly language program. Maybe it's not compatible anymore with what I've done. Let's see if I load gh. Oh, maybe. Same issue. Okay, no problem. Parse. Anyway, you can write them, but that's not something that you want to do really easily. There is a bunch of, I would say, not really nice program on that one, because it's all over the places in terms of name. But if I do a run right now, I'm sure it's not going to be able to execute because I didn't load the program, so I can reload. I would say, what was it? 7. Compile. And because I've asked to display the language machine program, it displays. I'm not really good at creating animation. Something that I want to add also. It's almost there, but it's not totally finalized. Here for the type that I have now, types. I've got unit 32. I've got unsigned int 16. I've got int, and I've got unsigned int. Just got t. I've got all this type. I need to do float because that's necessary to create a nice animation. And I also need. I've got also CRGB structure. That's easy part, and I need to be able to add. I want to be able to add user-defined structure. Also, that's something that I've got to add. So that's okay. That's okay. That's okay. That's okay. That's okay, and that's to be done. And to be done. Here it is. Yes, that's more or less what I had to say about scripting. So if you're interested in the first high-level version, that's the first beta. But I wanted to share with you this, I would say, proof of concept of actually creating a scripting language, which is fast. It's not really that scripted anymore because actually it's compiled into language machine and sent to the ESP32. With a store inside the memory of the ESP32. But here it is. I'm going to try to, when if and else is going to be implemented, I will create the game of life within my scripting language and to see if it works correctly. I hope so. Yes, drop me a message. Let me know if you want to try out. That's still a very early beta of everything, but I would be more than happy if you can use it with your own installation. Of course, at your own risk. Nothing's going to happen, nothing's going to break, but I will not provide too much support for the moment. Just let me know. Okay, what I'm going to do, I don't have any specific nice animation right now because actually it's not that's made to do, but I can add something into that one. So I've got my triangles. I'm going to reduce the luminosity of the rainbow and also 255. I'm going to reduce really low that. I'm going to put that into 64, that into 128. I'm going to reduce the number of rectangle which has display like to 10, and I'm going to say I want 3 times, so these are more spaced. So already if I compile this, you see the animation is totally different. Yes, I still need to execute the code because the killing is not working yet. That's soon to come. And you see the compilation is really fast. If it didn't have to display all the assembly language, we can be faster than that. And what I'm going to do, I'm going to add a small point that goes through. Let's I equal CRGB 255, 255, 255. Missing declaration of I in line 46 because I does not exist. It's L, which is my and normally we should see a small dot, white dot going through the let me remove that. Up, you can see the white dot here. And because I did not see what I was going through, let me re-show the show again the program. So what I've done in here, let's modify it live because you haven't seen it. Let's put it to 5 in here and put 5. So 5 rectangles, but with more space. And let's put yes, that compile, because I did not notice that I had my editor on top of it. And you see the red dot flying through. I could change that to, let's say, 10. And times 4. Let's put a bit more of lighten inside the background color. And you see it's really fast. If it was not for the displaying of that, of the assembly language, as I said earlier, it's really, really fast into the compilation and you can do funny stuff already. Okay, so thank you very much. Drop me let's say a comment, something, and bye-bye. See you soon.